Okay, this is notes section 5.3, notes 31, angle bisectors of a triangle. And the essential question is, what is an incenter? It is the intersection of all congruency lines of angle bisectors. And then theorem 31, angle bisector theorem says if a point is on the bisector of an angle, then it is equal distance from the two sides of the angles. If AD bisects angle BAC, then it's perpendicular to the sides, and that means that this side here is going to be congruent to that side right there. And that's the only case that proves that. Okay? Then theorem 32 is the converse of the angle bisector. It says if a point is in the interior of an angle and it is equal distant from the sides of the angle, then it lies on the bisector of the angle. So here in the blank is the word bisector. Okay? And it says that if the segment is perpendicular to the sides and is also equal, then that means that AD is, it bisects that angle. So that's what proves that it is the bisector, is that from the center to the sides is perpendicular and congruent. And that's what proves it to be the bisector. All right, then theorem 33 is where we have the incenter. This is where that name actually comes involved here, where all the points intersect in the center. It says an angle bisector of a triangle. Let me slide that down a little bit more. The angle bisector of a triangle intersects at a point that is equal distant from the sides of the triangle. That means that AP, BP, and CP are angle bisectors, so it cuts each one of those angles in half of that triangle. Then that means that PD right here will be equal to PE as well as PF. So in our blanks, we need PE as well as PF for our blanks. So those are perpendicular and they are congruent to each other. All right. The incenter is also where we can actually draw a circle that goes on the inside of our triangle. It's a neat picture to be drawing. On theorem, let me go down. That one's repeated. It says example 1 says find the measure of CBE. Realize since these two segments are congruent and then they are also perpendicular, you see the little perpendicular symbols, that means that this BE is the perpendicular bisector. So if the bottom angle is 31, then the top angle is also going to be 31. So that means that the measure of this angle, CBE, will actually equal 31 degrees as well. And that'll be our answer. Okay, on number 2, we have a picture of a spider web. It says the spider is positioned on its web relative to an approaching fly, and the opposite side of the web form congruent angles. All these angles in here are congruent angles. Will the spider have to move farther to reach a fly toward the right edge or the left edge? So here is the spider. If the fly was to go over here to the left edge at this point, or if the spider was to go over to this side, which distance would they have to travel farther? And since this is the incenter of our picture, that means that distance, oops, I misspelled incenter. Let me try that again. Okay, since this is the incenter, then that means it's actually perpendicular, and that means this has got to be congruent to each other. So neither side is faster. I lost my, oh, there it is. Either side is So neither side will be farther since they are equal distance. Okay. On example 3, let me slide that up a little bit. Okay, so for what value of x does P lie on the bisector of angle J? Well, for P to be actually on the bisector, it means these two segments have to be equal. So I'm going to set them equal to each other. So I have 2x minus 5 is equal to x plus 1. So I'm going to subtract the x from both sides. And that leaves me just 1x minus 5 is equal to a 1. When I add the 5 over to the other side, it tells me that x will equal 6. So when x is equal to 6, this is the case, then P is actually on the bisector. So that'll be our answer. Okay. If I go to flip the page over, and I have example 4 at the top. In the diagram, L is the end center of the triangle FJK. Find LK. If I look here in the picture, LK is right here. Let me get the highlighter. And let's make this small. Okay, so LK is right here, which means it is going to equal this distance here. Those two things equal. And what I do notice is that this right here, whoa, that big marker there, is a right triangle. So, oops, it didn't fill in very well. But this is a right triangle. So if I actually look at this as a right triangle, and I stand it up correctly, yeah, well, as best as I can here, the LK is what I'm looking for. The bottom HI is 12, and then the diagonal is 15. Well, for trying to measure different sides of a triangle, I have to use Pythagorean theorem, which was a squared plus b squared is equal to c squared. And the trick of this formula is to know which side is the c side. And hopefully you remember that across from the right angle, or the longest side, is our c side of our formula. If I plug these values into my formula, I have x squared plus 12 squared is equal to 15 squared. I have x squared plus 144 is equal to 225. I want to subtract the 144. And that gives me x squared is equal to, I believe that's 81. And now to get rid of the square, I have to take the square root. And that'll give me x is equal to 9. So this distance here, which is Li, is 9, as well as Lk. So Lk's length will be 9. Okay, on example 5, it says find the value of x. Notice we have the lines are congruent, the segments, as well as being perpendicular, which means this line going through the center of your angle is the bisector. Since that's the bisector, that means these two angles here are congruent to each other. So I can set them equal. It'd be 3x minus 5 will equal 2x plus 5. If I subtract the 2x from each side, I'll just have x minus 5 is equal to a 5, because these guys cancel out. When I add 5 to the other side, those cancel out, and x is equal to 10. And that solves my problem. When x is 10, I can plug them in and see that these two angles will be congruent. Right, on number 6, we find the value of x, and notice it has the perpendicular, and then it tells you these angles are bisected, so that means this has to be the perpendicular bisector, the angle bisector, which means these two segments have to be congruent to each other. So I'm going to do 8x is equal to 7x plus 3. I'm going to subtract these 7x, and that'll give me x is equal to 3. Oops. This would look like an x. There we go. And that would be my answer. It would make those two segments equal to each other. On number 7, do you have enough information to conclude that AC is a bisector of DBA? At this angle DAB, if I'm looking at it, I do see that my segments are congruent to each other, but also notice right here that it does not show that it's perpendicular, so this would be a no. And say the angles are not perpendicular. Oops. Let's try that again. Okay, let's see. Oh, not typing the right thing. Need to be in the pen. There we go. Okay. All right, let's slide it down a little bit more. Number 8, and except before, suppose you are not giving HL or HI, but you are given that JL is 25 and JI is 20. So JL, let me slide back up. JL is 25. All right. JL right here is 25, and JI right here is 20, and we are asked to find what? LK. Alright, so LK, let's go back up. LK is this length here again, and notice it's still that same triangle, just on the opposite side, where 25 will be the C side, the hypotenuse, and 20 will be the bottom. So that means I'm using the same formula that I had above. So I'm still going to do x squared plus 20 squared is equal to 25 squared. Well, it's still going to be x squared plus 400 is equal to 625. I want to subtract the 400, and that gives me 225 is equal to the x squared. And then to get rid of the square, I have to do the square root. I want to take the square root of 225, oops, which means the x is equal to 15. The x represents that sign that I have, so that means LK is equal to 15. Okay, you need to answer your summary here on an end center, what it is.